Today we're going to talk about implied ratios. That'll allow us to solve problems like this. If 12 books weigh 20 pounds, how much do 30 books weigh? So we've actually learned a strategy that we could use for this. For example, using unit multipliers. If we were using unit multipliers to solve this kind of a problem, what you might do is say, we want to know what 30 books are. And we might multiply that by a unit multiplier, which tells us the relationship between books and weight. And we know that 12 books is equal to 20 pounds. I'm putting it in this way because I want the books to be able to cancel with this books. If I had a problem where I wanted to find out how many books were in a certain amount of weight, then I would do that weight times the reciprocal of this. But basically, this allows me to kind of cancel my units, cancel books. I can also make sure to reduce. So I know that 6 goes into here 5 times, 6 goes into here twice, 2 goes into here 1 time, 2 goes into here 10 times. And so I know that the answer should be 50 pounds. And it makes sense because if I went from 12 books to 30 books, I basically doubled the number of books I had, plus a few more. And so I expect that the weight should double and plus be a little bit more. So I do expect that it would be a little more than 40, which it is. So I feel like this is the right answer. Okay, so we could have used unit multipliers to solve a problem like this by thinking about kind of what is the ratio of weight to number of books. But we're going to learn another way that might be more straightforward. So we could also use a ratio box to solve this problem. And what we've seen so far are things where we had a ratio written in this first column and then a total amount written in this column. But for the problems like today, we're actually going to instead modify this so it's case 1 and case 2. So on my rows, I'm going to have the pounds and the books. And I'm going to look up here and say, okay, so in the first case, I have 12 books, and that weighs 20 pounds. And in the second case, I have 30 books, and I want to know how much they weigh. So this is the thing that I don't know. I could put a question mark here. I could put the variable that I like the best, X, or maybe B for books, something like that. And now that I have this ratio box, we know that we can use this ratio box to write some proportions. So I can say that 12 over 20 is equal to 30 over X. This is the proportion that I could write. Once I have that, of course, there's some different ways of solving. We could say, what is it that I could multiply 12 by to get 30, and then multiply 20 by the same thing? That might be a little bit easier to do if we reduced this first. Or I could also set up my cross products as being equal to each other. I do like to just work with smaller numbers, and I know that 12/20ths can be reduced. So I know, for example, that 4 goes into both of these. So 4 goes into here 3 times, 4 goes into here 5 times. Oops. So I could have also written this as 3/5 equals 30x. This makes it really easy to use that first strategy, right? So 3 times what equals 30? 3 times 10 equals 30. So I'm going to do 5 times 10 also. And x must be 50. If I were setting my cross products equal, what I would have ended up doing is saying 30 times 20 is 600, and that equals 12x. And then I would have to say x is equal to 600 divided by 12. And that would also give me 50. So I basically just make a box, and that helps me stay organized so I can see how I can put in the information that I have, and then see one box will be empty, and that will be probably the one that I'm solving for. And then this stays nice and organized so that I can easily write a proportion. So here's another problem. Kevin rode 30 kilometers in 2 hours. At that rate, how long would it take him to ride 70 kilometers? And I'm always going to suggest that you start by estimating an answer, because that way, if we do somehow get confused and things end up in the wrong direction, we might be able to catch that. So I know that in 2 hours, he can run 30 kilometers. And basically, he's going a little more than twice that distance. So my estimate is that he's going to be a little bit more than twice 2 hours. So maybe 4.5, I don't know, maybe 5 hours, something like that. If I wanted to use unit multipliers, I would say, okay, I care about 75 kilometers. And I'm going to multiply that by some sort of relationship between kilometers and time. And since I have kilometers on the top here, I'm going to put it in the version that has kilometers on the bottom and time in hours on top. So I know that that relationship is 30 kilometers per 2 hours. And so I could cancel that and reduce. And then I'm going to multiply across and say it's going to be 75 divided by 15 hours. And I know that 15 goes into 75 5 times. So that would be 5 hours. And like my estimate, I kind of estimated that it would be something close to 5 hours. So that's good. So I feel very confident about that answer then. I don't think that I did it wrong. If I want to solve with a ratio box, I can have my case 1, case 2, and I'm going to put my distance and my time. So in the first case, Kevin rode 30 kilometers in 2 hours. And in the second case, he rode 75 kilometers. And we don't know what this is. I'm going to put a T for time. I can write my proportion now. 30 over 2 is equal to 75 over T. Of course, I can reduce this. So let's do that. Let's say 15 over 1. And then, again, I can use my strategy of thinking about, well, 15 times what is 75, and then multiply 1 by that same amount to get T, or I could do my cross products. In this case, the cross product is pretty easy because it's actually just 75 times 1 is equal to 15 times T. And so we already did this up here, but when I divide 75 by 15, I get that T equals 5. Here's another problem. I'm sorry that it's getting a little written over here, but if 6 bales are needed to feed 40 head of cattle, how many bales are needed to feed 50 head of cattle? So again, if I'm estimating, I'm realizing that it's actually not that many more cattle than I had in the first case. So I don't know, maybe 7 or 8 bales, something like that seems like it would be appropriate. So again, if I wanted to use unit multipliers, I would start off with my I would start off with my 50 head of cattle because that's what I care about. And then I would multiply that by some relationship between bales and head of cattle, with my head of cattle now in the bottom so that it kind of cancels my units. So I would be doing this multiplication. I know that I can reduce this to just 5 over 4. I can reduce this to 2. So it would be 15 divided by 2, 7.5. And notice that like I estimated 7 or 8, and I'm actually exactly in between. So that sounds really good. If I wanted to use my ratio box, I would have cattle here and bales here. Case 1, case 2. And in the first case, I used 6 bales of hay for 40 cattle. And in the second case, I have 50 cattle. And I want to know how many bales of hay, maybe a B for bales. And so I could write my proportion as 40 over 6 equals 50 over B. And again, I could use any of my strategies. I could think, okay, well, if I multiply 40 by 5/4, then I'm going to get 50. Or I could do my cross products and set them equal to each other. Anything you want. I always like to reduce first. So if I, let's just do the cross products this time. I could say that 20b equals 150. And again, I get 7.5. Here's the last one. I wonder if you can do this one on your own and bring the answer to this in class. So here we have 5 is to 15 as 9 is to what number? This is a little bit of a different kind of problem as we have, but basically we're thinking about the relationship between 5 and 15. So what is the relationship between these two? And then that same relationship will apply here. So think about this one. Think about how you could set it up in your case 1, case 2. And instead of having some labels here, we don't really know what 5 and 15 are referring to, but you can say the first number as compared to the second number. And hopefully, if you keep that straight, so this is the first number, here's the first number, here's the second number, here's the second number in the statement. Hopefully that can help you figure out what goes in which box. All right, I'll see you Monday.